Question 6b. The diagram shows the trajectory of a ball thrown horizontally at speed v meters per second from the top of a tower h meters above ground level. The ball strikes the ground at an angle of 45 degrees, d meters from the base of the tower as shown in the diagram. The equations describing the trajectory of the ball are x equals vt and y equals h minus half gt squared. Do not prove this, where g is the acceleration due to gravity and t is time in seconds. Part 1. Prove that the ball strikes the ground at time t equals the square root of 2h over g seconds. The vertical displacement when the ball strikes the ground is 0. So we're going to solve for t, the equation, h minus half gt squared equals 0. So this comes from the formula for the vertical displacement. I'm going to set y equals 0. Multiplying all terms by 2 to eliminate the fraction of half, we have 2h minus gt squared equals 0. Moving 2h over to the other side and multiplying by -1, we get gt squared is equal to 2h. Dividing both sides of this equation by g, we get t squared is equal to 2h over g. Then taking the positive square root of both sides of this equation, since we're dealing with time and time needs to be greater than or equal to 0, we get t is equal to the positive square root of 2h over g as required. Part 2. Hence or otherwise, show that d equals 2h. The following are the marking guidelines for question 6b, part 2. For 1 mark, we have make some progress using that angle at which the ball strikes is 45 degrees or equivalent merit. And for 2 marks, we have correct solution. At time t equals the square root of 2h over g, the ball strikes the ground at an angle of 135 degrees to the positive x-axis. Hence, dy dx is equal to -1 at the point where the ball strikes the ground. Now in the question, it shows the ball striking the ground at an angle of 45 degrees, but that's relative to the negative x-axis measured in a clockwise direction. By convention, angles are always measured from the positive x-axis in an anti-clockwise direction. Hence why we need to use 135 degrees. And that's also why dy dx is equal to -1. So 135 degrees corresponds to a gradient of -1. So -1 is equal to negative gt divided by v. So dy dt is equal to negative gt and dx dt is equal to v. Rearranging this equation to make v the subject, we get v is equal to gt. And we call that equation number 1. Now x is equal to d, which is the distance from the origin at time t equals the square root of 2h over g, where x is equal to vt. So this is the equation that gives us the displacement in the x direction of the ball. So when t is equal to the square root of 2h over g, the horizontal displacement has reached its maximum extent, and that is at the point D. So substituting the square root of 2h over g for t, we get d is equal to v times the square root of 2h over g. But v is equal to gt from equation number 1. So d is equal to gt times the square root of 2h over g. But t is equal to the square root of 2h over g. So d is equal to g times the square root of 2h over g times the square root of 2h over g. So that's the same as squaring the square root of 2h over g, since we're multiplying these two identical terms together. So we have d is equal to g times 2h over g. The g's will cancel, and therefore we have d is equal to 2h as required. The following is the feedback from the Marking Centre for question 6b. For part 1, most candidates correctly substituted y equals 0 into the vertical displacement equation to show this result. Some candidates correctly verified the result by substituting t equals the square root of 2h over g into the vertical displacement equation to show that y equals 0. There were some inefficient algebraic approaches, with candidates first finding the Cartesian equation, then substituting x equals vt to show the result. Weaker responses stated that y equals negative h and incorrectly obtained the result. Candidates need to be careful with notation, making sure the radical sign includes all required terms. T equals the square root of 2h over g, not t equals the square root of 2h all over g. For part 2, in many responses, candidates stated d equals v times the square root of 2h over g, but had difficulties linking this to the velocity components and or dealing with the negative velocity when the ball strikes the ground. Many responses were marred by fudging of negative signs when tan 45 degrees was given as y dot over x dot rather than the absolute value of y dot over x dot.